Let's go over exam number 6 and let's start our conversation with problem number 1. So problem 1 is the trigonometry problem. What happened? Parabola. So projectile motion creates parabola. Here you have a soccer ball. This is Messi. He kicked the soccer ball at 30-degree angle with initial velocity of 30 meters per second, and there is a goal post over here, and the ball overshoot the goal post. This is the goal post, France goal post. The goal post is 8 meters long. However, the football, the soccer ball went over the goal post, and I want you to know how much. So once you know the height of the soccer ball at this location, right here, the red, so the final answer is going to be the blue, red minus the blue, minus, so this is red, and this is blue. So final answer gonna be red minus blue. You already know blue. Blue is 8. You don't know red. So our job is to find the red, and then we know the answer. Okay, good. That's what we're gonna be doing. We also have one more information, and that is from Messi's foot to the France goal post is 50 meters long. Okay, so let's do step. This is our step 1. As always, you have to draw a diagram, and that is step 1. So let's do step 2. Step 2 is trigonometry, Vx and Vy. What is Vx? Of course, V initial cosine 30. What is V initial? Of course, 30. And this is V initial sine 30. What is V initial over here? Of course, 30. And cosine 30 is 0.87 times 30 is 26 meters per second, and sine 30 is 0.5 times 30 is of course 15 meters per second. This is step 2. Now I'm going to do step 3. Step 3 I'm going to do of course on this side. Step 3. Step 3. This type of problem I gave you many problems like this today. So D has 2 type of components. One is the dx, which is Vixt plus half axt squared, and you know ax, acceleration due to gravity at horizontal direction, is 0, and now dy is equal to Viyt plus of course half ayt squared, and you know ay has a special name, and that is g, of course. Now the dx, you have the dx. What is the dx? Dx is 50, so you have dx 50. You have Vix, which is 26, so you have 26, and the t is that you are looking for. So t is 50 over 26, which is 1.9, taking just 1 decimal. Now that you have this, you want to know the x, comma, y. What does that mean? What is your x? X is the t. And what is your y? Y is the height. Y is the red plus blue. That's the y. Red plus the blue is the y. Y is the whole thing. That's the y. When the time is 1.9, what is the height of course, the soccer ball? That's fine. So then dy is the final trying to find, or you can say height. Instead of dy, you can say height. Viy in physics, you have to know what you're solving for. Those equations meaningless if you don't know what you're solving for. Okay, so height. Viy is of course 15, and t is 1.9. And then we're gonna use negative 10 today. So negative 10 divided by 2, which is negative 5t squared, and t is of course 1.9 squared. So the height is 10.45 meters. So now that you know the rate, so let's make it our rate. Then this 10.45, so 10.45, and then that is 2.5 course meters. All right. So at 1.9, the goalpost is 8 meters, but the soccer ball, the height of the soccer ball is 10.45 meters. So the goalpost is lower in height than the soccer ball. Therefore, the soccer ball missed the goalpost, and that's trigonometry in action. You will see trigonometry in action in many more problems, and you see this type of thing many more time today. We have 9 more to go. Problem number 2. Problem number 2, you'll see that 10 kilogram object. This is a rubber on ice. Rubber is moving with constant velocity, meaning the acceleration is 0, meaning the net force is 0. On ice, this is ice. If rubber move on ice with constant velocity, that means we have to be on the 1, 2, 3 at location 2 of applied force versus friction graph at location 2, and location 2 you have a mu k, because location 2 is of course constant velocity. Good. Once you understand that, once you know that you have to use mu k, then your job is easy. You just go ahead, find your Fg, which is mg, which is 10 times 9.8, which is of course 98 Newton, and your normal force is equal in magnitude, opposite in direction, 98 Newton. You want to find your force of friction, and force of friction, I show you have to use mu k and of course Fn. Mu k, if you use the reference table, I put a circle over here, so you see that this is for rubber on ice 0.15. So you're going to use 0.15 times of course 98, and that gives you 14.7 Newton. If this is 14.7 Newton, this must be also 14.7 Newton, and only that it qualify to be location 2, and it qualify to be constant velocity, it qualified to be Newton first law, it qualified to be acceleration is 0, it qualified to be net force is 0, it doesn't qualify for this reason, and it doesn't qualify for this reason. Now we're going to do problem 3. Problem 3, as you know, we spent an entire week, and of course you also did a lab at 2S14. So problem 3 has to do with the kinematics, putting together kinematics and dynamics just by scouting, crouching down, and then crouching up, and you are setting yourself into the air, and that's problem number 3. So at first, what do? You are just standing, doing nothing. We call it A, and then you are scouting. So this is called B, and this is called B, and then this is you almost send yourself in the air, and this is C, and then you are in the air. This is called, I don't know what I'm gonna call. Okay, so let me call this is also A prime. This is B. Let's call this is C, and you back to the ground again, and this is called C prime. All right. So what we are interested is this two. Okay. Why? Because of course the velocity is 0 over here, acceleration is 0 over here, net force is 0 over here. There is nothing going on over here. The person is aiming to jump up, so the person is doing something, scouting. All right, so that's very good. That means the velocity, this is called location A. So the location B velocity is more than 0. You can find out acceleration is of course more than 0, and net force is of course more than 0. All interesting thing happening over there. Fn is over here equal to gravity, right? Because of course Newton first law, don't write Newton's third law over here. This is just Newton's first law, because it doesn't satisfy Newton force pair on two different objects. So this is just Newton's first law. At G is equal to Fn. Everything is good over here. Nothing is going on. Fn is also greater than 0 over here. Okay, Fn is 0 over here. All right. So now let's find the velocity over here. This is our goal, to find velocity over here and acceleration over here. That's our goal, and then we're gonna move on with that information. So quickly find the velocity. Of course, this, as you see, that this kind of create a nice parabola, and of course this kind of creates, as you see, that this is scouting. So the first we're going to use the parabola for obvious reason, and then we're going to use the scouting, and then this is the parabola that we are using to find, of course, the velocity. Vf squared is equal to Vi squared plus 2ab. Of course, we're going to call this one the parabola. We're going to call this one what location you want to call it, location C maybe, I don't know, and this is location B. You want to find the velocity at location B. So good. So then of course C is 0, Vb is you have 2 times A is negative 10, and you are in the air for 0.30 meter, and you are crouching for 0.40 meters. Okay, so you have 2 times 10. I really have to show you the algebra, otherwise you're probably going to get confused. Plus 2 times, so velocity is 2.5 meters per second. So you're going to use this velocity to find the acceleration rate here. So to find the acceleration, we have to use this crouching. So Vf squared is equal to Vi squared plus 280. Now we're going to make it B, and you're going to make it A. Where is A? A is this one, all right? A is right here. So B we already know, 2.5 squared is equal to A. Nothing is going on A. Velocity is 0. So 2 times A times D is 0.40. So acceleration is 7.8 meters per second squared. All right. Now what we're going to do, we're going to show the Newton third law over here and Newton third law over here at A and B. So let's first start with A. So this is our Earth, and this is Mr. Barry. So Newton third law, what happened over here is we're going to call this one, this one, all right, this one. Force on Mr. Barry due to the Earth, or the Earth pulling Mr. Barry to the center of the Earth. So Earth pulling Mr. Barry to the center of the Earth. This is how you're going to read it. And how you're going to, this one you're going to read it, F Mr. Barry, Earth get pulled by Mr. Barry to the center of himself. So this one you can find by mg. All right. So that means you have Mr. Barry is 100 kilogram, 100 times 10, which is 1000 Newton. And this one equal in magnitude, opposite in direction. So just you can write 1000 Newton, or you just can write G m Mr. Barry m Earth over R squared, which is also going to give you 1000 Newton. You can check that. It's a quick math. You can check it. So this is good for the first one. Now we're going to do the location B. Location B, this is location A. Now we're going to do location B. So this is Earth, and again this is Mr. Barry. So what's going on at location B? Location B, you have the force Mr. Barry push Earth. The pushing force on Earth by Mr. Barry. Pushing force on Mr. by earth pushing force on earth by Mr. Barry, and this one earth pushing force, okay, on Mr. Barry, all right, which is equal in magnitude, opposite in direction, okay. But we can calculate it. We can calculate this one, mg plus a. We already know everything. So this is 100, and this is g, which is 10 plus, so 17.8. So this is 1780, of course, Newton. If this is 17.8 Newton, this is of course 1780 Newton. That's not it. We have two more, and that is of course this one. The downward gravity, which is Fg, is equal to mg, which is 1000 Newton. And the upward, which is of course Mr. Barry pulling out to the center of himself, Fg is equal to 1000 Newton. You should not call it Fg. You can call it Fg. You can call anything you want, but you should be calling that just like Earth, Mr. Barry is pulling the Earth to center of himself. That's what it is. Okay, now let's find the acceleration of Mr. Barry. Acceleration of Mr. Barry will be what? This is the acceleration of Mr. Barry. Acceleration net force. Net force is of course 1780 minus 1000, which is 780, divided by m, which is 100, so is 7.8. And hey, acceleration is actually 7.8. Now the acceleration of Earth, let's see. Acceleration of Earth is of course 780. How? Because it's negative 780. Because if the Earth is, as you take a look, 780, which is negative, plus 1000, so negative 780, and divided by 6 times 10 raised to 24. All right, so acceleration is negative, of course, but is 10 raised to negative 22 meter per second squared. 10 raised to negative 22 is actually 0. It's nothing. So while Mr. Barry moving upward with because Mr. Barry push on the Earth, okay. Mr. Barry push on the Earth. That's why Earth push Mr. Barry back. That creates some net force, which is 780. That creates some acceleration, which is 7.8. And that creates some velocity, which is of course 2.5. That sent Mr. Barry to the sky. Hopefully you understand problem number 3. The problem number 4 is just like problem number 1. Problem number 1, you have to use trigonometry. Problem 4, you have to use trigonometry. Problem 1, Messi kicked the ball, and instead of this one, Messi kicking the ball, you are pulling. So the other one is just you kicking it, which is kind of push, and this is now pull. Let me see whether we can understand. So a wood box, this is wood, moves with constant velocity. On wood. So wood on wood, constant velocity. That seems like a good combination. So this is Messi kick the ball with initial velocity 30 meters per second, but you pull it applying, of course, 150 Newton. Messi kick the ball with, of course, 30 degree, and this one you also pulling it with 30 degree. You see the similarity. Very nice. The message one, you have to find the both component of the vector. Now also you're going to find both component of the vector. The x component is 150 cosine 30, and the y component is 150 sine 30. And this is going to give you 230, and this is going to give you 75. 30.87 times 150, so it must be 130. Okay, don't forget to write Newton, don't forget to write Newton. Okay, Now, let's understand it. Let's draw the box again. What do we know? Before we draw the box, what do we know? We know that is constant velocity. Constant velocity. What does that mean? Does that mean that's location 2? Location 2. Location 2 means mu k. Mu k means constant velocity. That means, of course, Newton's first law. That means acceleration is 0. That means net force is 0. Excellent. What does that mean? That means the box, both component, the x component, okay, because it is moving, is never off the ground. It is moving on the wood. Which force allow it moving on the wood? X component. So x component of the applied force. This is applied force at the x. This is applied force at the y. Applied force. X component of the applied force is equal to FF. If it's a little bit smaller, then it is of course a little bit smaller because they both are same. That's why there is constant velocity. That's why acceleration is 0. That's why net force is 0. So if we know this one, we know this one. Or if we know this one, we know this one. It seems like that's all we need to know to find Fn. And that's our goal. What is FF? We know what FF. FF is mu k Fn. And mu k, wood on wood, is of course mu k. And mu k is 0.3. So we're going to update it. 0.3. FF. So at the x direction, the friction always work at the x direction and never at the y direction. So this is Fx and this is Fy. Alright? Fx is how much? 130. Fy is how much? 75. So 75 has nothing to do with this guy because this is constant velocity. This one is equal to this one and this one is equal to this one. So you make a statement. Ff is equal to Fx is equal to 130 is equal to, what is the equation for Ff? Mu k. Alright. F. Alright. So what does that mean? If everything is same and 0.3 Fn. If everything is same, we're just going to use this 2. Alright. If you do use this 2, so that means 0.3 Fn is equal to 130. So Fn is how much? Let's do it here. Fn is 130 divided by 0.433 Newton. Hopefully you understood this problem. This is the last problem I'm solving is because I have a family emergency, so I have to go home. However, I will send you the other tutorial as soon as possible, hopefully by the end of midnight. That would be the tutorial for the second part of the E6 and then the tutorial for 3 assignment for week number 16. The problem number 5 is again just like problem number 4. However, why? Because this is again wood on wood. So this is wood and this is also wood. Whenever something wood on wood is straightforward, you just look at the reference table and you see it right there. However, instead of giving you 2 kilogram, I give you 20 Newton, all right? When I give you 20 Newton, that means I give you 2 kilogram. You understand that? Okay, so this is made of wood. This is also made of wood. So what is happening is I applied force is 8 Newton. So there is no y component, but hey, let me help you understand something. Applied force at x and applied force at y. So you can, the last one you did 150 cosine 30. Right now you can do 8 cosine 0 and then 8 sine 0. This is how you should play with this at home so you get the hang of it. During the test you can finish it with no problem. So you see that there is no if you draw the free body diagram, this is how it should look like, and there is a force of friction. Of course applied force is bigger because why? Because there is an acceleration this direction, and that's what we try to find. So applied force is bigger than force of friction. Force of friction is mu k. Why is that? Because there is an acceleration. That means in a friction graph, of course, this is location 3. That means location 3, Newton's second law. That means there is an acceleration. That means there is a net force. Now we are trying to find the acceleration. So what is, of course, the mass? Let's find the mass. Mass is, of course, mg over g. So 20 Newton over 10 meter per second squared. So mass is, of course, 2 kilogram. Now this is good. So I'm not going to erase it. So this, since it is here, this is mu k, and mu k means wood on wood is 0.3. Okay, so far so good. So I have mg, I have fn, which is equal in magnitude, opposite in direction, and this is what's going on right now. Now I'm going to use Newton's second law. So Newton's second law, F equal ma. All right. So F means you have big F, and you have a smaller one, ff, and m is, of course, we found 2, and acceleration is that what I asked you to find. Fa, you know, is 8. Ff, you're going to find ff now. Ff is mu k fn. So mu k is, of course, 0.3, and fn is, of course, this is 20 Newton, so this is 20 Newton. So 20. So this must be 6. So minus 6 is 2a. So as you see that 2a is equal to 2. So acceleration is 1 meter per second squared, of course. So hey, I have to finish it here. The second part I'm going to do it from home. I have a family emergency to take care of.